Now I'm going to stick a push pin in the top of this object and push it down so it's nice and flat up against the surface. Okay, so if I tilt this, we can see that the push pin is coming out here at an angle, and if we have it over on this side, we can see that it's coming over this way at an angle, so that if I set this down on the original object and put this pin parallel to the push pin, we can see that the pin is tilted so that it has a component, so that a vector in the direction of the marker would have a component in this direction, and we can also see that it has a component in this direction, and we understand clearly that it has a component moving up toward the camera also, so that this vector would have an I, a J, and a K component. We want to determine what the components of that vector might be. Now we can consider this to be an arbitrary vector perpendicular to this flat surface. We could consider this push pin to be maybe a unit vector along this surface. Not along, but perpendicular to the surface. So what we want to do is we want to figure out if there's a way to find the components of some vector perpendicular to this surface, and then maybe if we could, having found a vector perpendicular to the surface, find a unit vector in that direction. Now, any vector perpendicular to this surface is going to be perpendicular to this edge. Clearly, any vector in this direction will be at a right angle with this edge. And similarly, a vector that's perpendicular to the surface will also be perpendicular to this edge, meaning that any vector perpendicular to the surface has to be perpendicular to our first fundamental vector and our second fundamental vector. Now we want to call those vectors something, so I'm going to just label this first fundamental vector. I'm going to call this V, and that's again going to be our 4i minus 2k vector. And our second fundamental vector I'm going to call W equals 2j minus 0.4k. Now, among the things that we know about vectors is that, for example, we can calculate a dot product. The dot product V dot W is just the magnitude of V multiplied by the magnitude of W multiplied by the cosine of theta, where theta is the angle between the two vectors. Now, what vectors are we talking about? We go back to this surface, put it in the standard position. We're talking about this vector and this vector. What's the angle between those two vectors? We can see if we orient the surface so that the normal vector, vector perpendicular to the surface, is pointing right at the camera, we can pretty clearly see that this edge and this edge don't make a right angle. If we use these components, we can easily do this calculation. We've got the components of V and the components of W, so it's easy to calculate the dot product, and it's easy to calculate the magnitudes of these things. So we can substitute what we know and solve for theta. Now, I'm not going to go through the details of that right now, but we'll do that shortly. The other thing that we know, if we understand the basic vector operations, is that if we do the cross product, V cross W, this thing has two properties. One, the magnitude of V cross W is much like we see here, magnitude of V, magnitude of W times the sine of theta. But unlike the dot product that just gives us a number when we calculate it, V cross W gives us a vector, and this is a vector which is perpendicular to both V and W. Just a little side note, the word to here is redundant. This symbol means perpendicular to, so actually I've written perpendicular to, but to avoid confusion, I've written the word to in there, so I've created a little confusion to alleviate what I find to be a little more confusion with the notation. Okay, anyhow, if we can calculate v cross w, then we have what we're after. We're going to have a vector that's perpendicular to this surface, and we're going to find that to be very useful.